Rachel Perlman. I work as a consultant at RRS, Resource Recycling Systems. We do work with the public and private sector as well as institutions like universities on circular economy issues, waste management, recycling, and just sustainable materials management in general. I'm based in Arlington, Massachusetts, and I'm really happy to be here.
Thank you. I'm Gretchen Perry. I am here. I am the president of Mass Recycle, a statewide nonprofit organization for sustainable materials management. And I also have a background of having a degree in genetics and finding my way into the waste world after that. I just recently left my position at Republic Services. So I was a sustainability manager there for 9 years, and therefore have seen the intersection of the medical world, the waste world, and all of the above. I look forward to talking about that.
Good morning, my name is Connor Carlin. I'm the president of a company called Clefs Advisory, which was set up last year. And we like to say we operate at the nexus of plastics and sustainability, because it's quite broad and vague, and I want to talk to a lot of people about a lot of different things, frankly. I'm also just finishing my term on the Society of Plastics Engineers. I was currently the past president, now serving on the SP Foundation Board, and we were able to get accreditation to the United Nations Environmental Program for the plastics treaty discussions, because we expect a lot of work to actually happen after a treaty is implemented, not so much the development of the treaty itself. So in addition to that volunteer work, I also serve as an advisor to some startups, preferably in clean tech and plastics material space.
Good morning, my name is Juanita Trabert. I work for the City of Newton as the Director of Sustainable Materials Management, and then I also sit on the Board of Directors with Gretchen for Mass Recycle. I am the Vice President, and also on that organization, that nonprofit, I lead an entity called the Product Stewardship Council for Massachusetts. We try to advocate, well, we do advocate, but we try to get laws passed for extended producer responsibility. And in my role, I work a lot on policies. I pay attention to what's going on nationally and internationally as far as extended producer responsibility. And in my day job of the City of Newton, I manage everything having to do with trash recycling, household hazardous waste. I manage a drop-off center. So I see both the policy side of things, and then I'm also on the ground, kind of like the physical picking stuff up and putting stuff down somewhere else. So I'll be moderating the session today. Just kind of slid in right on time. So it's a very exciting topic to be thinking about waste reduction and management of plastics. There's a lot going on in this space. A couple of colleagues that I have that have been in this industry for a long time, I ran into one of them at a conference last year, and she was saying, I've been doing this for 30 years and nothing has ever felt so kind of energized, and like there's so much momentum, there's so many projects happening, there's so much investment happening in this space to try and make things better, to try and become more sustainable, to figure out waste reduction and kind of the whole movement towards dematerialization. So how can we accomplish the same thing with less material? Because you save money, it creates less waste, so kind of creating that efficiency. So today we're going to touch on those things. I wanted to get started by just touching on the policy framework in the state of Massachusetts that we start from, which there's not a whole lot. But in Massachusetts, there's these things called waste bans. And so it's a waste disposal ban that the state has put in place in an effort to try and have things be recovered and recycled as much as possible. So the types of materials that are banned from disposal include our very common kind of single stream recycling, so cardboard, plastic containers, glass containers, metal containers. And so that's really kind of the backbone and the starting place from a policy perspective on the state for in incentivizing more recycling and waste diversion. There's a lot of other initiatives to, I would say, reduce waste, increase reuse. There's grants to incentivize that the state offers, and I'll have Gretchen touch on one that would be relevant to you all. And so with that starting place, again, there's not much. I mean, even those are enforced at the disposal level. So it's not like if I were to put a can into the trash over here, anyone's gonna say anything. There's not, there's no recycling police. It's not going to come down on you that hard. But if a recycling truck comes to your facility and goes to where it's dumping, the trash truck comes to your facility and goes to where it's dumping the trash and it's 50% cardboard, that truck could get rejected. And then it could end up being a fee or an extra fine on you from the hauler, the waste hauler that handled your trash. That's really, again, like this very low bar that we're starting from. So why don't we start hearing from our panel? Let's talk about plastics in particular. In the medical industry, it's difficult to recycle many plastics. Gretchen, tell us about that.
Sure. Juanita and I do a podcast at Master Cycle, so you'll see a lot of this. Okay, so it starts off with the idea of, let's start with those triangles, okay, and the misinformation about the little triangle around every resin code, okay? I'm sure a lot of you know this, but I'll just throw it out there for anybody who's still in the dark about this. There's a triangle around every number, and yet they are not all easily recyclable. And in fact, really we're looking at 1s, 2s, and 5s. But in Massachusetts in 2018, we went over to just thinking about containers with lids. Okay, so bottles, jars, jugs, and tubs. So thinking about it differently, and that's important. But also in 2018, before that, a lot of laboratories were triple rinsing, defacing, and throwing in their containers, their solution containers, their bottles, that sort of thing. They were also throwing in things like pipette tip boxes, which we all know is really clean plastic. And in 2018, which was when the recycling world turned upside down because China, the largest buyer of recycled products, walked away. That caused a shift in the whole system, the creation of Recycle Smart, which is a statewide campaign, guidelines statewide, so wherever you are, your hauler, it should be doing the same thing, and the recycling facilities all signed on to take the same items. And that's important because what happened at that point is the Department of Environmental Protection, who organized this conversation, said, what things do you want in the bin and what things do you not want in the bin? And one of the things that fell out of the bin, as we put it, was medical plastic of any kind. So at this point, and this is hard to hear. It was hard to tell this story in 2018 because I understand that I'm literally telling people in laboratories, no, you can't put that distilled water bottle into the recycling, okay? And this was very challenging. It was my job at the time working for Republic to have these conversations to get out ahead of this and make sure that recycling was clean and was what we needed it to be, because there's a market for the things we were asking for. There was no market for things like pipette tip boxes. They would end up as contamination in most recycling facilities. So, and if you've ever really looked at some of the bottles that you've got for solutions, they're not normal plastics. They're different, okay? They have different qualities about them, and that makes them hard to recycle as well. So that was when, so I'll throw this out there, something I didn't say when I introduced myself, but in looking for an answer for all of the scientists that I talked to that year, trying to find a way to handle that clean medical plastic, I ended up inadvertently co-founding a company called Green Labs Recycling. So, yeah, that's how I ended up in this whole medical plastic arena, but the fact is that we know that there's a lot of There's containers that are good, clean plastic, like the tip boxes, solution bottles, things like that. There's also a whole lot of film plastic that is, it's created specifically because it has qualities that are important to you as the end user. And it's a challenge to take all of that film and figure out how to make it into something new, how to give it a second life. And so that film, that's still a great niche for somebody who wants to develop a business on that. I think there's still that need here, but there are at least, and you'll hear from Polycarbon a little after this, there are now 2 businesses in this whole medical plastic, picking up pipette tip boxes arena, at least. I think I've said enough. Back to you, Anita.
Let's stay on the plastic subject. Connor, can you give us your perspectives and takeaways from your recent trip to the Associated Plastics Recyclers Conference?
Yeah, so the PRC is hosted by the Association of Plastics Recyclers, a DC-based group, like most DC-based groups, lobbying on behalf of their constituents, which are primarily plastics reclaimers and recyclers. And what they have struggled with, and they've repeated many times, is that there's more capacity to recycle plastic than there is plastic collected and given to the recyclers. So they need more material to improve both their economics and their capacity utilization. The problem is that PCR, post-consumer materials, is much more expensive than virgin plastics because there's so many more steps involved. So it has to be collected, it has to be sorted, it has to be reprocessed, and not all materials will be processed the same way. So at the PRC, they continue to push for solutions that include long-term contracts. So when the Cokes and the Pepsis of the world are saying that they're going to do what they say they're going to do by 2025 or some other number that's divisible by 5 somewhere out in the future, they are not actually doing the most impactful thing, which would be to send a signal to the market, which is we will buy PCR at X price for 5 years, and that will let it flow through. So this is the push for responsible end markets, but demand pull through the system, which really is at the core of the challenge of recycled plastics today. At PRC, they also had a textile conference for the first time. Textiles are actually a bigger potential problem than what we think about in terms of plastics packaging. There's a lot of polyesters. In fact, some of the macroeconomic figures on the amount of fiber produced and consumed in China alone will shift markets worldwide. In fact, the amount of PET globally produced is much more used for fiber than it is for packaging, except here in North America because we don't make as much fiber. So that polyester world, that PET world, which we're more familiar with because we see it in bottles, is actually a fairly small component of the overall picture. And that's before you get into a subsector then, like medical plastics, in rigid trays, for example, PETG, which is the blue one which you're most familiar with, is not compatible with PET. We should be moving away from it. There are solutions from Eastman for copolyesters that don't require the addition of glycol. But in general, as Rachel might know, the medical device manufacturers operate under different rules and are probably shielded to some extent from some in the EPR legislation because they're covered by FDA rules. And there's quite a few medical device manufacturers that don't want to have to obey 2 different sets of rules, which makes perfect sense.
Yes, I completely agree that does make sense. Rachel, why don't you touch on some of what Connor said about, and just kind of incorporating plastics, but maybe expanding the conversation bigger into overall kind of circularity, how the medical sector fits into that, and any room for kind of waste reduction improvements.
Yeah, so in our current system, the traditional system, we take waste our products, so we aren't handling them in a circular fashion, they're more of a linear fashion, right? So we end up with everything we consume ends up either being recycled or wasted, and in the medical space, a lot of that ends up being wasted, right? Going to disposal. So if we think about a more circular model, we can think about, can we use products as services? Can we use some of that plastic or material more circularly, so can we recover it and make new products, ideally that same product, out of that material, or refurbish or remanufacture that product. So in the medical space, I'm not an expert in the medical space, but I did my PhD at MIT. We worked with the labs there, so I have some experience. And I would say that in some senses, plastics aren't always the first thing you want to approach for circularity from the medical side, because plastics are often selected in the medical space or in the biotech space because they are disposable, so you can guarantee some elements of sterility, and kind of the one-time use is designed often right for a purpose, so that nurses moving very quickly can use a one-time thing safely. And so from a waste perspective, where I come from, I think we want to think about what's going to have the highest impact, even though there's a lot of anger around plastics and their use of plastics. We should think, I think, kind of from like an analytical perspective, is it worth it to choose plastics as what we're going to change? And I'd say sometimes, maybe. So if we think of going to the dentist to have our teeth cleaned, they're often using stainless steel tools that they make sure that they make sterile later, right, and autoclave. So there are cases where we can avoid the use of plastic, which is the first thing in our tier, right, is avoiding, reducing. So in that sense, I would think about, are there choices there? And I think that's a question that probably is more about operations and logistics in a hospital or in a clinic setting, rather than really a material perspective. But yeah, there's a lot of clean film coming out of hospitals and out of a lot of businesses. So a lot of retailers, like the big bulk stores, they have a lot of film plastic too, and behind the scenes, a lot of that plastic actually does get captured and recycled. That's some of the only film plastic in the US that does get captured and recycled, because it's high quality, it's good, and it's clean. And yeah, I think from like a policy perspective, a lot of this can happen. So as I said, I was at MIT for a while, and a lot of the impact can actually come from arrangements with vendors and institutions. So one of the biggest ways I found in my research that MIT could have an impact through its procurement was working directly with its vendors to try to get components back to the vendor for remanufacturing or for reuse. That could include pipette tip boxes that are sterilized and used again. It could be reusable pallets that are sent back. So that whole supply chain and reverse supply chain can be really valuable, because a lot of medical equipment that is like a consumable comes along with some durable goods. And then I think from the device side, there's a lot of opportunity there too, because if you have manufacturers, even local manufacturers in the Massachusetts region, can you remanufacture those pieces of equipment or extend their lifetime? So in the world of circular economy, one of the best things you can do is extend the life of a product. So can we make that large proprietary high-tech piece of equipment last longer? Are there components of it that we can fix and update, and software that is can be evolved over time and not expire? So I'm sure a lot of you are thinking about those things, and those things make a big difference. And then at the end of life, is there a plan? So that device is highly specialized. It might have a lot of valuable rare earth metals. It might have batteries that need to be disposed of safely, and all of those things help. So can we plan, instead of only making things and being done with it once we sell the product? Can we make a plan? Can we lease that product and then take it back with a plan? So those are some of the things that I think about when I think about circularity in the med business.
Yeah, there's a lot there, and definitely touching on the emotion around plastics. I think that's front of mind for most folks tuned into the news on this, or maybe your personal views, like takeout containers. They make people see red, and that certainly has, I would say, moved the conversation more in this policy direction. And it's something that's getting captured in, I would say, the conversation around bigger policies. So I mentioned before extended producer responsibility. Does everyone know what that is? Show hands who doesn't know what that is. Okay, so let's talk about that, because I would say it's something on the horizon, and I don't, to what Connor said, I don't think that it's going to be tremendously impactful to the medical space, because there are a lot of exemptions and carve-outs in those laws very deliberately, because the medical industry is serving a higher purpose and has so many unique waste streams that would not be well advised to capture in a law that would be very stagnant or hard to change. So extended producer responsibility is a policy mechanism or policy concept where there is a law that gets passed that requires the producers of either a product or packaging for a product to financially pay for the end-of-life disposal or proper management of that product or packaging. And so this is how in Europe they get 95% recycling rates, because this system is aligned and incentivized in that direction. So what it looks like in practicality is that this law gets passed, producers are required to form a nonprofit or even several nonprofits, and then this nonprofit collects fees from the producers of, again, a specific product. Let's just use an example, let's say batteries. So that's something that we're exploring right now in Massachusetts, to get battery extended producer responsibility, or EPR, into place. And so what would happen is, if the law gets passed, the battery manufacturers would either create or hire a nonprofit to manage a collection network for them. And then they pay into this system that pays for the collection network. So this is already happening in a couple of other states for batteries specifically. The closest one is Vermont. They had started with a law on primary batteries, and then they added rechargeable batteries. So now they have all batteries that are covered under this law. Now that there's been this evolution in several states across the country, there's now some buy-in and support from the battery manufacturers, because they want to be good stewards of their product. They recognize that there's some problems that are happening, especially fires at waste facilities, even some, it could happen, it's happened at Boston College BU, where a dumpster that had a lithium-ion battery caught fire. And so that can be very damaging or disruptive to any type of facility. So it's a material that has a lot of attention on it. And so now that we've seen this evolution in policies, these laws getting passed, the battery manufacturers want to adopt one law, and they want to be in support of it and be part of the conversation, as opposed to states going on their own and passing laws, and they end up having a patchwork of policies that they have to follow. So that's, of course, inefficient and disadvantageous to them. So they are now advocating for this type of law. They're saying, please regulate us. We are in agreement on this set of provisions. So in Massachusetts, we have a bill that is introduced in both the House and the Senate by legislators that are in leadership. So we're hoping that that will create some kind of clout or sense of urgency around this issue that we are actively advocating for. And so I think batteries is a good example where in the medical industry, it's specific to a subset of batteries, not all batteries of all sizes, but it's called portable batteries. So it's basically a battery that's under 4 pounds and isn't specific to a medical device. So if it's just let's say a remote control in a hospital room that has AA alkaline batteries, that would be captured in this law. So those batteries would end up being able to be collected at no cost, and that material can get captured So creating this kind of circularity, whereas right now, the protocols for those to go into the trash, we can instead capture those and, well, again, hypothetically, when this law gets passed, we can capture those, capture that material, and kind of keep it into the supply chain. So extended producer responsibility is on the horizon. The big, I call it the big fish, is packaging. So the materials that we've talked about here about recycling, in particular, like that Gretchen mentioned, bottles, cans, jugs, and tubs made of plastic, aluminum, glass, and then cardboard. Those materials are captured under a packaging EPR framework, and there are currently 6 states that have passed this type of law. Maine is the closest to us, and they were the first one to pass it in 2021. So that law was passed in 2021. They anticipated a 3, maybe 4-year runway, but now it's looking more like a 6, maybe 7-year runway for that law to actually take effect and be implemented, because it is such a robust set of rules and protocols that need to get developed, and there's so many different stakeholders that need to come to the table and have a say, and everyone needs to kind of agree on things, and it needs to be feasible. There's just a lot of things to cover, and it's the first time in this country that that's happening. Who would like to touch on and expand on anything related to extended producer responsibility?
So I'd like to say that it's, anybody who's spent time in the EPR world can feel like it's taking a really long time to arrive anywhere, especially in Massachusetts, just saying. But I'm excited to say, now that I'm not working for Republic, I can say that it's been really challenging getting haulers and the waste industry to the table on this, okay? And they're a big player because they're the ones handling the material. They stand to lose if an organization, PRO, I'll let you explain PROs, but if an organization established by EPR decides to make local changes that are not in their favor, they stand to lose. And so up to this point, they've been, up to about, I'd say about 4 years ago, they were not interested in having their conversation. I've seen that behind the scenes where people have asked their opinion, asked them to be in on it, and they simply said, we don't want to talk about that. Like, totally stuck their heads in the sand, all right? And now that they realize it's happening, whether they like it or not, they are now coming to the table and at high levels having these conversations, which is excellent because it's really important, to not undercut the infrastructure that already exists and the people who have already invested in that infrastructure. That's what they're afraid of. It's understandable. Change is hard. Okay, so I think though that there is a movement on that side, and that will help. So I'll just throw that out from my perspective.
Yeah, so we work at RRS a lot on EPR issues and trying to help implement it once it's passed, or work with states interested in passing EPR. EPR for packaging, while I think it is the ultimate solution for a lot of packaging, I do think a lot of medical and medtech materials would end up being exempt out of the policy, and because also EPR may take a number of years to still come to Massachusetts for packaging, I would encourage all of you to think maybe in more of the pre-competitive collaborative approach, or working directly to establish markets and incentivizing. So if you are thinking about the carrot and the stick approach, how can we incentivize? So maybe the state is going to provide more carrots before we go for EPR. We do the stick approach with bans, right? So will we be banning medical plastics, for instance, from disposal? I don't think that's going to happen in the near future. And even if it does happen for certain materials that are used in the medical setting, I doubt that those will be under scope, that they will most likely be exempt as well. So perhaps in the meantime, it makes more sense to think about trying to find a market for a material, maybe with, so for those who have a familiarity with the term industrial ecology, which was a predecessor to circular economy, maybe there are other hospitals or other manufacturers, other producers in the Massachusetts area that are looking to do something similar, and you can combine forces. The more material you have, the more likely you're going to find a purchaser. So oftentimes haulers only want to take a certain quantity that can fill a truck, and recyclers only want to take a certain quantity, like Save That Stuff or other recyclers or connectors to recycling want a sufficient quantity. So one idea is to try to aggregate a certain material, make sure it's clean, and try to get it recycled. And then I would kind of lean back on that procurement side. Can you work with those who you're procuring from to make sure that your materials are low impact or lower impact? So maybe they can't be post-consumer recycled content, but maybe they can be made of a material that has a lower impact in some environmental impact category, whether that's greenhouse gas impacts, eutrophication, something else. And so there's a lot of smart people in this room, and you can look towards studies like life cycle assessments or just general EPA guidance to kind of pick lower impact materials. So the lower impact, if a product has a lower impact in its generation stage, then what you do with it at the end of life, well, it matters, but it matters less. And I think that is worth considering.
Very well said. Connor?
Yeah, I'm 100% in agreement with Rachel's final comments there, and just to be slightly contrarian, the talk about the circular economy is very much at the risk of letting the perfect be the enemy of the good. And I think the term has become overused. It's simply not applicable in some worlds. I'm not a physicist, but I believe the second law of thermodynamics comes into effect in some of these discussions. So while we should be thinking about sustainability most broadly, it's about reducing our impact on the environment. Fundamentally, that's it. That doesn't mean that things have to become circular all the time. It can absolutely mean having the least worst impact, because there's always going to be trade-offs, especially in the materials world in which we live. So life cycle assessments, even though they are imperfect, they are getting better and better. It's become a highly specialized field in the last 15 years. Speaking of industrial ecology, I think Tom Kimmel might know Tom Gloria, who's been a long time proponent of industrial ecology here in the New England area. And the level of specialization in LCAs now is really not for the faint of heart anymore. But with more and more data, it's becoming more and more precise, and people are able to have a scoring mechanism to understand the impact of their choices on the environment. I think that's fundamentally the case. EPR has been around for a long time, right? I mean, it's been in California for mattresses, for paints, for carpets. And EPR is not new. The Europeans do it well. They're also used to higher fees for almost everything because electricity is more expensive, petrol is more expensive, taxes are higher. Yes, they get other things in return, like trains that work. But it's not to say that innovation can come from restrictions, right? Innovation can come from the sticks, and what we've seen in the States is we've seen everybody who had a seat at the table in terms of even bottle bills in Massachusetts, right? I mean, this is people who fought tooth and nail against doing the right environmental thing until the wind changed somewhere, and now all of a sudden they're in favor of it. So the message there really is to think more holistically and get involved on finding the solution before you're beaten into submission and having to tell your constituents that now you're going to have to pay more, when really it didn't have to be like that in the first place if we had been a little less selfish and thought more broadly about the bigger goal that we're trying to achieve.
Okay, so that kind of brings up a great point as well. So economics play a big part of this. So Europe, right, with their not so much lands, definitely more people, have come up with different ways to deal with things. Anaerobic digesters were there for food waste long before we got them, and I think that particularly in Massachusetts, not only we have a great intersection of innovation and a lack of space. Okay, there's a lot more people than there's land here, and that that changes the dynamics financially. So there's not a lot of landfills left. There's an established number of waste to energy facilities, and everything else has to get railed out to somewhere else, or trucked maybe, but mostly railed. And that means all of our trash is going somewhere else, which means it's expensive, and that changes the dynamics in terms of new technologies coming in, whether it's pyrolysis or any kind of depolymerization that will make it more possible. And lots of people have lots of opinions on this, but the fact is, if I have tons of trash or plastic that I can't do anything with, it is not recyclable, that using that locally to, whether it's create new plastics or create fuel or whatever, is more sensible than sending it out of state to be put into a landfill just because somebody has a lower environmental bar there. And so I think that there's options that are going to be coming in that, we will have to judge as we go along. Is this the better thing, And yes, you can lose your mind doing life cycle analysis on these things.
I mean, the healthcare packaging recycling council, people are familiar with them. Yamina Chu, she's in Cambridge, I think she just recently left there. So they just released the third phase of a very long study, 6 years I think in total, on advanced recycling opportunities for medical plastics specifically. And some of the findings were interesting, some maybe not so much, but in terms of space constraints in patient hospitals and the medical sector, like space constraints a huge deal. The opportunities seem to be in reverse logistics, which I think Polycarbon knows something about, so that is an opportunity for entrepreneurs, right, for new business models to come into play there. But in terms of the recycling, advanced recycling technologies such as depolymerization and pyrolysis, not all plastics are equal, right? We've got olefins, we've got polyesters, they don't react the same way in some of these. So what a lot of plastics are recycling, whether mechanical or advanced chemical, they require clean streams, which means sorting, which means collecting separately in the first place. So whether it's mechanical or advanced, the same premise has to be true in order to get the yields, especially in advanced recycling. It needs to be as clean as possible, because some of those yields, when there's paper labels or mixed materials going in there, it reduces that yield, it reduces the economics, it creates byproducts that are not economical in terms of technical nutrients in the industrial ecology, so those aren't there either. But they just completed that. I think they have to do more in more regions. There's 9,000 recycling programs in the United States, which makes it very difficult to get federal legislation as it is. But in the medical sector specifically, I think we're going to need more regional programs and collaborations to figure this out.
Very well said. So speaking of some of those local or regional programs, Gretchen, why don't you share with us information about the Waste Reduction Innovation Grant that Mass DEP recently released?
Sure. Okay, so one thing that the DEP does really well in Massachusetts is to give out money to inspire people to create, innovate, and do better, whatever that is, invest in the infrastructure for recycling and diversion of all kinds. And this most recent grant just came out, I just read about it this week, and it's RIG, W-R-I-G, in case you're looking it up, and I will say I'm impressed that the DEP finally came up with an acronym that is pronounceable, because before this it was a lot of consonants. So the idea is that it's got two main categories. It's about taking an innovative idea from, and they're looking specifically for successfully demonstrated technology or systems, and taking it to the next level of commercialism. And so there's two categories. One is the $50,000 to $100,000 category, and the other is the $500,000 to $2 million category. So, but it is all about innovating to take more material out of the waste stream, and whatever that looks like. So, yeah, excited about that. Massachusetts does that well, and I think it's a wonderful pairing with the number of brains coming out of Massachusetts who are all really interested in these great problems, very, we have a lot of smart people here.
So that grant is open now. Do you know when the due date is?
I do not, sorry.
I believe it was late June or early July. So if you're interested in that, I highly recommend looking into it. It's a new grant series that, again, DEP has a record of having a very robust grant program, kind of feeding dollars into the system, and particularly with recyclers or like recycling technology, taking someone that has a kind of proven model but needs help scaling, moving that in the right direction. So let's see, we've touched on all sorts of different things. Do you want to ask questions from the audience at all? I think so. We have a few minutes. Does anyone have any questions for our panelists? Yes?
I'm curious, so a lot of the talk has been about the reduction, recycling, and whatnot. I'm curious your guys' thoughts on biodegradable materials. Like, how do you guys think about that as an avenue for improving the environment or reducing greenhouse gas?
Okay, so the question was touching on biodegradable materials as opposed to just recycling or waste reduction. Rachel?
Yeah, it's a really good question. So there's a couple things at play. So when we think about like compostable products, which that term is often used, you might see biodegradable, you might see certified compostable. So those products can be useful choices in some cases. The challenge in Massachusetts is kind of related to the space constraint question. We don't have a lot of composting capacity in Massachusetts that wants or can take compostable plastics. Compostable fiber is often more okay with those facilities, but in any case, for a number of reasons, including that those fiber products often have a compostable plastic layer on them, a lot of the programs here have turned to a food waste only program and are being sent to co-digestion. And so what that means is that those programs don't want compostable plastics. So all of that is to say, the choice when you're manufacturing or procuring is, it's really tricky. You probably want to stay away in the current climate from compostable plastics until we have a reliable end market locally, because we don't want to be trucking our products too far, and they may not be desired, they therefore may not be accepted. So for instance, if you live in the city of Cambridge, your food waste can go to anaerobic digestion, but compostable plastic is not accepted at curbside. Same with a lot of parts of Boston. And so in a private setting, if you can find a composter to take your material who explicitly will accept compostable plastics, then you can make the procurement decision to have compostables. Then there's the questions of LCA, is it worth it? That's a whole other question. But before you make any procurement decision, please make sure that someone will take it at the end of life.
I always have to bite my tongue and say total disaster. Because it's biodegradable, it's perceived as like a solution to something that is better solved in another way. And what happens when things biodegrade? There's under certain circumstances and certain conditions which are less available than the most amount of recycling that we do. So it's, I think it's a solution in search of a problem or the inverse. But where the difference with compostables are, and I have an ongoing bet with people at Keurig Dr. Pepper that compost is never going to take off, except for maybe with coffee pods. Because there's like 18 grams of coffee in a 2-gram pod. It's a vehicle for compost. So actually, I'm probably going to lose that bet, I think, in the end. But it's really dependent on infrastructure and collection. And if you don't have it, it's not a good solution. Right? You shouldn't be looking to biodegrade things if it's not going to biodegrade. If you don't have the area in which to do it, even from an LCA perspective, monomaterials, polyethylenes, polypropylenes are extremely efficient and extremely low impact and have always scored better on LCAs going to LC for packaging.
I totally agree, and yes, it has to go to the right end site or it doesn't do any good whatsoever. And what usually ends up happening, from my experience, is that people will walk away with, say it's a compostable dish, even if it was compostable packaging of any sort, And they don't throw it away where there was a compost situation. They take it back to their desk and then they throw it away in the regular trash, which is going to go one of two places. It's either a landfill or it's a waste energy facility. The waste energy facility, did you mean to burn that? Was that really the best way to deal with the compostable thing? No. And the landfill situation means that now something that is organic ends up underground, trapped in a sanitary landfill where there is no oxygen, and the intent then, we had hoped to not have it break down underground because that creates methane. And only about 20% of the landfills in America are set up to capture that methane. So therefore, its chances of ending up in the right place are really minimal, and there are just not, as she said, there's just not that many places that want to accept them. Because when people start throwing in things like compostable dishware or compostable packaging, they throw lots of other things in too. Or they take what looks like plastic cups that are compostable and throw them into the recycling. And now my petroleum-based plastic is getting mixed up with sugar or corn or whatever that's made of, and that doesn't melt together well, So there's just so many challenges with biodegradable, which sounds amazing. Okay, so I don't think we want to encourage everybody to start throwing things simply on the ground and let them break down. But I have definitely heard people say that, like, oh, I could just toss it out the window into the woods, You're like, that is not a great way to think about this problem at all.
I'm really glad that that question was brought up because it is an important part of this conversation. Do we have time for one more? I think we need to wrap up. Okay, we're gonna wrap up. I hope you guys got a lot out of this, at least food for thought and things to kind of take back and research more and find how they'd be relevant to you.